In this lesson, we're going to be talking about the different types of chemical bonds. By the end of this lesson, you should be able to compare ionic and covalent bonding and contrast ionic and covalent bonding. So one thing that we have learned already that we're giving a little bit of a refresher on is the atom, and the fact that it is the smallest unit of matter, and it is indivisible. It is as small as it can go. Electron shells. So in a neutral atom, we know that the atomic number is equal to the number of electrons. And the electrons are in different energy levels, or what we like to call energy shells. Electron shells determine how an atom behaves when it comes in contact with other atoms. So one thing that we did talk about in ionic naming is the octet rule. This is when atoms gain or lose or even share electrons so that they can have 8 in their outermost shell, or what we like to call the valence shell. So for example, carbon, it would like to gain 4 electrons. Nitrogen is typically going to want to gain 3 electrons because it's easier for the element to gain 3 electrons than lose its 5 it already has. Oxygen is going to want to gain 2 electrons because, for the same reason as nitrogen, it's going to be easier to gain 2 electrons than get rid of the 6 that it already has. So here's some other pictures and examples. If you're looking across the first shell here, hydrogen has 1 electron in its shell and helium has 2. And looking down through the second shell, you can kind of see that as you move across, the amount of electrons in the outermost shell gains. So lithium has 3 electrons, 1 in its outermost shell. Beryllium has 2 in its outermost shell. Boron 3, carbon 4, so on and so forth, all the way to neon, which has 8. Looking at the third shell, we're in the same situation. Sodium has 1, magnesium has 2, aluminum has 3, silicon 4, so on and so forth as you're moving down the line, all the way until argon, which again has 8, just like neon. Looking at your periodic table, you can see kind of how this trend fits with your atomic radius. The more electrons that it had, the smaller the atomic radius, and this is due to the fact that there is more energy and more attraction between the electrons and the protons, so it's pulling that atom in. If you do remember graphing those atomic radius, you started with lithium, and then as you went down from beryllium, boron, carbon, it started to decrease, and then you shot back up at sodium, and it did the same thing again. And that is because looking at how many electrons you have and how many electrons are in the outer shell. If there's more electrons, there's going to be more energy and more attraction between the electrons and protons. But the more there are in the outer shell, the more it's wanting to keep its electrons, and so it makes itself smaller and pulls itself in, which causes the decrease in the atomic radius. So chemical bonds, this is an attempt to fill the electron shells. There are 2 different types of bonds that we're going to talk about, which is ionic bonds and covalent bonds. And if you're looking at the pictures down here at the bottom, we've got lithium and fluorine on the left picture. And if you notice that there's an arrow here that's indicating that lithium is giving its 1 electron in its valence shell to fluorine. Fluorine has 7 electrons in its valence shell. So if lithium gives up its 1 electron, this 7 then becomes 8. And then lithium will get rid of this outer shell, and it will have 2 electrons in its outermost shell, which for the first energy level, if you remember, the max it can hold is 2 electrons. So then lithium would be happy as well with just 2. In the picture on the right here, we've got fluorine and fluorine, and you can see that they are bonding. They are sharing their 7th electron with each other so that they both have 8 in their outer shells. And sometimes that is the easiest way to go about it, because if one of these atoms were to give away 1 electron to the other atom, well, then one is going to be left with 6 electrons, which that's not stable, and the other one's going to have 8, which is stable. So this way, it's the best of both worlds. They're sharing their electrons, they both have 8, and they're happy. So the first bond we're going to talk about is ionic bonds. This is a bond that forms between 2 ions by transferring their electrons, by one giving one up. So this was the case with the lithium and the fluorine, and the lithium gave away 1 of its electrons. And in this picture, you can see that sodium is giving its electron to chlorine, which then causes sodium to be positive and chlorine to be negative. So the formation of ions from metals, we know that metals form cations, they give up electrons, and ionic compounds are formed when metals and nonmetals react, as we know from learning through ionic naming. Metals, again, they lose their electrons, causing them to form cations, and we know that a positive ion is formed when there are more protons than electrons in the atom. So basically, all of this information is review from either learning about atoms, learning about the periodic table, or doing ionic naming. But now we're taking all of that information, putting it together, and figuring out the reason this is all happening is because electrons are being transferred to other atoms so that they can be happy atoms. So they can be stable and have as many electrons as possible in their outermost shell. We know that group 1 metals, these typically form +1 cations. Group 2s typically form +2 cations. And group 13s, this is the column right after the transition metals, starting with boron. These typically form +3s. We've learned this information either in the periodic table or doing ionic compounds, but this is a great thing for you to always keep in the back of your mind. So the formation of a sodium ion. This is something that we have talked about. Sodium, it loses 1 electron and becomes a sodium +1. So we're going to write this as sodium starts off with, well, its atomic number is 11, so it has 11 electrons. It's going to lose 1 electron, which then means it has 10 electrons. Okay, so this is the sodium. This is your sodium ion. This one has 11 electrons, 11 protons. This one has 10 electrons, 11 protons, which means we have 1 more proton than electron. All right. What about magnesium? In this case, magnesium is losing 2 electrons to become a +2 ion. So your magnesium, and this is your magnesium ion. Magnesium starts out with 12 electrons. It gives 2 away, and now we have 10 left. This one, 12 electrons, 12 protons. There's a 0 difference. Here we have 10 electrons, 12 protons. There's 2 extra protons in this one, which gives it that +2 charge. So some types of typical ions that you're going to see with positive charges. We've got hydrogen, lithium, sodium, and potassium, all with +1s. Magnesium, calcium, strontium, and barium, all with +2s. And aluminum with your +3. So let's do a learning check real quick. So how many valence electrons does aluminum have? Looking at its group, the fact that it's in group 13, it typically has a +3 charge, which means that it would lose 3 electrons. Another hint to learn how many electrons are in its outermost level is if you count across and skipping the transition metals. So if you're looking at lithium and you want to go to boron, so if you count across from lithium, lithium is 1, beryllium's 2, boron's 3. That means that boron's going to have 3 electrons in it. So let's do learning check B. What change for aluminum is going to give it an octet? Aluminum's typically going to want to lose 3 electrons. So then what is the ionic charge for aluminum? Well, if it's losing 3 electrons, that means it's going to have a +3 charge. Awesome. We answered all those questions. Now, let's check the ionic charge for the following. So if we have 12 protons and 10 electrons, what would our charge be? Well, 12 minus 10 leaves us with 2, and the number for protons is bigger than the number for electrons, so that means we're going to have a +2. If we have 50 protons and 46 electrons, what would our charge be? Well, 50 minus 46 gives us 4. The number for protons is bigger than electrons, which means it's going to have a positive charge, so it's going to be 4+. What if we have 15 protons and 18 electrons? 18 minus 15 is 3. The number for the electrons is bigger than protons, so that means we're going to have a negative charge, so it's going to be 3-. So formations of nonmetal ions. In an ionic compound, nonmetals get their electrons from metals. That we know. But unlike metals, nonmetals will add the electrons to reach their octet, which then gives them a negative charge. So typically their ionic charges will be 1, 2, or 3. So let's try a fluorine ion. So fluorine is gaining 1 electron to become its fluorine ion. And we know that's going to be fluoride, because anion, you name the ion, adding IDE to the end. Okay, so this says that fluorine is gaining 1 electron. Well, fluorine starts with 9 electrons. If we're adding 1 electron, that means we're going to have 10 electrons in the ion. So, if we have 10 electrons and 9 protons, that means we're going to have 1 more electron than protons, because 10 minus 9 is 1, and the number for electron is bigger than proton. So, let's take a look at this picture here. If we have a sodium and a chlorine atom, the sodium has 1 electron in its valence shell, chlorine has 7. Typically, sodium is going to give up its electron to chlorine, so then sodium will have a valence shell that has 8 electrons in it, because it'll get rid of this 1 shell and it'll use its second level. And chlorine will have its 3rd valence shell with 8 electrons from the sodium atom, and we would call this sodium chloride. So ionic bond recap. This occurs between atoms of metals and nonmetals. The bonds form by the transfer of electrons from the metal to the nonmetal, and they produce charged ions in all states. Examples are like sodium chloride, calcium chloride, and potassium oxide.